we're going to learn evidence calculation involving multiple interest formulas. By multiple interest formulas, actually we are talking about multiple types of cash flows. So we said we have learned different types of cash flows: present value, annuity, future value, right? And if you remember in the previous classes, we only talk about how do we convert a single type of cash flow to another single type of cash flow. So we talk about, for example, in this one, what we have on the timeline is just the annuity, right? That's our single type, one type of cash flow. And the question usually is, how do you find the future value from that annuity? How do you convert the annuity to a future value at the end of the timeline? So what you want to do is to find F given A, okay? And you can see that you always deal with a single type of cash flow, okay? And another example on the right side, sometimes you are given the present value, and then you're looking for the annuity equivalent to that present value, right? So again, you're find A given P, and in this case, you are still dealing with single type cash flows. Okay? But in the reality, it's not always the case that you always have single type of cash flow to convert to compound to another time or to another type of cash flow. Usually what you have is, for example, on this chart, on this diagram, during the 8 years, you have different types, multiple types of cash flows going on. First, you might have cash flow going out by the end of the period 1, and then you have another volume of cash flow going out at the end of period 2, and then you need to spend another amount of dollars by the end of the third period, right? There are three cash flows, okay? And compared to the time at 0, these 3 cash flows are all can be called some future cash flows because they are happening at a later time compared to the time 0. We always call the value at time 0 present 0, okay, which means it's a present value at 0 time, or we label it as P0. And so all the cash flows happening later than that time point will be some future cash flow compared to this time 0, okay? So on this cash flow, you have a future cash flow at time 1, you have another future cash flow at time 2, and you have another cash flow at time 3. So there are multiple cash flows. Although they are the same type, they are all future value, but there are multiple ones with different amount. And beginning from the end of the 4th period, you can see on this chart on this diagram, we have annuity, which is $400, Okay, so this is the second type of cash flow, which is annuity. So in this diagram, we have future value and we also have annuity. Okay, they are on the same diagram. So for this problem, we need to find a way to convert different types of cash flow to some single type of cash flow. We can convert the F to some present value at 0 time. We can also convert the annuity to some present time value. And the present value from the future values, which is F1, F2, F3, we can say that's the first part of that present value. And the part of the present value will be converted from the annuity, and that's gonna be the second part. Okay, so in the end, if we want to know what is the total present value out of converted from the future values and the annuity values, then actually we need to know that it is from two parts. One part is from the future value, F1, F2, F3. The other part is from the annuity values, the 400, beginning from the end of the 4th year and until the end of the 8th year, continue until the end of the 8th year. Okay, so this is what is what I want to talk about. It's the multiple cash flows, multiple types of cash flows going on the same cash flow diagram. Okay, so that is more complicated, but it is more real case. Okay, so we need to find a way to calculate this type of problem. All right, so to explain the approach you're gonna use to calculate this multi-cash flows, multi-types of cash flow problems, here is an example, and it is very very useful case because you always find such problems in your future work. So if you are a business owner, you want to have your construction company, you want to buy equipment at the beginning, right? Maybe excavator. You either want to buy it or you want to lease it or you want to just rent it time to time. You have different options. So here, just imagine you are going to buy an equipment, maybe an excavator, for your factory, for your construction company, and you want to use it for 8 years. Okay, so that's the year, the lifetime you want that equipment to serve. You can either buy a second-hand equipment, right? If you want to have something cheaper but still workable, you can find a used one, just like a used car, right? Another option is you buy a new one. Well, they cost different, but the maintenance is also different. Okay, just imagine if you buy a second-hand one, which means your initial payment could be cheaper, but during the lifetime of that equipment, it might need more maintenance because it's already used by someone else. So it's easier to get broken, and you might need to spend more every year to maintain, to check, and to repair. Okay, and compare to a new one, I mean. And at the end of that 8 year, you might want to resell it to or trade in. And then that equipment has been used by a previous owner and you, so it's gonna be very old. So the price you can resell it is gonna be very low. Make sense? Okay, another option is you buy a new one, a new excavator, maybe. So the new machine is brand new, which means the quality is very good. So every year, the money you spend on maintenance, on checking it, repairing it, might be very low compared to an old one, compared to a used one, right? And also, in the end of the year, if you want to resell it or trading, the price for this new equipment could be higher than the second-hand one because it's just used by one owner for 8 years. So it's still very new, okay, in a good condition. But to buy this new machine, you need to pay much more than the second-hand one. So you see the difference, right? And that's very typical. No matter if you want to buy a new machine or you want to buy a car or you want to buy a house, right? This is the similar situation you need to face. So I would say this example is very good. So let's just see if we have two options like this. How do we decide which option is better than the other one? Based on the cost. Okay. All right, so think about that. If we only consider cost, so for option one, we have initial payment as cost, we have yearly maintenance as cost, we have the but in the end we're gonna sell it at a lower price because it's used one. So all these cash flows we can convert them to the present value, P0. And then you can imagine it could be negative value. If it's negative, it means it's your cost, right? So that cost is something, actually equivalent to the price of the equipment, the maintenance fee of the equipment, and the salvage fee at the end. Now keep that value in your mind. So you already have a value from option one, right? That's your true cost. And for option two, you also need to spend, one cost is the price. Second is the maintenance, yearly maintenance. Third, you're gonna receive some money at the end if you trade in. But those cash flows, you also need to convert them back to the present time so that you can compare these two options. Okay, so and you can imagine that maybe for the second option, you also have a negative value because that's the money you spend going out. But the two values are gonna be different. So in the end, you want to have a P0 for the alternative one. You also need to have a P0 for the alternative two. Okay? And you want to compare this to P values. Okay, we write P0 option 1 and the P0 option 2. So just let you know, you're gonna have two P values from these two options. And then you want to compare which one is less negative because they're all cost. They're all money going out. So whichever is less negative versus P0 option 2, which one is less negative? That's gonna be your better choice because you're gonna cost less if you go with that option. Make sense? And this negative, it doesn't mean it's the value lower than 0. Okay, not lower than 0, but mean meaning it's a cost. Okay. So now you can understand the logic. Okay. So we want to convert for each option, we want to convert every cash flow back to a present time. And then we compare the value of the present value, the value of the present cash flow for both options and find the better solution. Okay. So now let's take a look at these two options. Option 1, you buy a used one at 18,000. Okay. And then every year the machine needs this much 34,400 to operate and maintain. Okay, you want to use it, you want to maintain it. That's the total net cost every year for using that machine. At the end of the year, you can trade in or sell at 2,000. Okay, so the 18,000 is the cost, so it's money going out, and this 34,400 is also a cost, so it's negative, and the 2,000 is something positive. Okay, that's just the symbol we use for accounting. Negative means it's a payment, positive means it's a receiving. Okay, and that's the option 1. Option 2, you can buy a new one at a much higher price, which is 60,000. That's your cost, so it's still negative. And every year, the maintenance fee and operation fee is gonna be 25,000. So you see that is lower than the 34,400 because it's newer, and still it's a cost, so it's negative. And at the end of the year 4, the machine needs a major maintenance, which will cost 9,400. Okay, so at the end of year 4, you're gonna have a major maintenance for this equipment, and that major maintenance is also the cost, so it's negative. And at the end of the year, you can trade in or sell at a higher price compared to the 2,000 for the option 1, right? And that's the money you receive in the end because you sell it, so it's positive. Okay, so these are the two options. Clear? And then now what we want to do is, first we deal with the first option. We draw the diagram, we convert the different types of cash flows back to the present time. Okay, and then we sum all the present time values together to get a total present value for option 1. So the first thing, you draw a diagram. Okay, so we can draw a diagram here. It's 8 year. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. At the beginning, you want to pay for the price. So that's a cash flow happening at the time 0. And it is going out cash flow, so it's an arrow going downward. It's 18,000. And after that, at the end of every year, the machine needs 34,400 to operate and maintain. So 34,400 is, that arrow should be longer than the amount of 18,000. And it's still going downward because that's the cost. So at the end of the first year until the end of the 8th year, as long as you want to use it for the previous 1 year span, you need to pay the maintenance and operation fee. And that annuity is 34,400. At the end of the 8th year, you can trade in or sell at 2,000. So that's your receiving. So it's a arrow going upward, and it's very short compared to the other cash flows. And it is 2,000. Okay? So now take a look at this cash flow. You have 3 types of cash flows. You have the first type, which is a P value, right? And then you have a second type cash flow, which is annuity. And you also have a third type of cash flow, which is a future value, right? Compared to the 0 time, this 2,000 is happening in the future time, right? So that's a future value. So you have 3 types of cash flows. 3 types of cash flows. Okay, and then you want to convert all the 3 cash flows back to a present time. Okay, so now what you want to look at is, wait a minute, so we need to write the interest rate, which is 8%. Okay, that should be given in the problem statement. Let me see if it's given. Yeah, it's 8%. Okay, so now what we're looking at is the present value at 0 time for all the 3 cash flows. So what is the P0? And we said it is converted from 3 different types of cash flows, right? So it is composed of 3 parts. Okay, so you can write P01. It means the present value from the first type of cash flow, okay, part 1. And that cash flow is the initial payment of the 18,000, right? And it is a type of p-value. And also we said it is a negative value because it's a cost. And this negative doesn't mean it's a value lower than 0. It only means it's a cost, money going out, okay, compared to the receiving. And you have another part, you can label it as P02, which is from the annuity. Of how much? Of 34,400. Okay, and we said the type is annuity. Okay, and then of course it's a cost, so it's negative. We have a third part of the present value, which is from a future value. That is the salvage price at 2,000. And we said what type is it? It is a future value. And it is a receiving, so it's a positive. Okay? So now you have 3 parts. And then you want to convert each part back to a present value. So what is the P01? What is the present value of a present value at 0 time? You don't have to convert anything because the 18,000 is already happening at the time 0. So there's no converting, no compounding needed. So you can just write negative $18,000, okay? And P02 is from the annuity, okay? First, it's negative. It's from the annuity, which means you are looking for a p-value given annuity, right? At the interest rate of 8%, and the compounding period is 8 years. So the equation you're going to use is A times a factor, which is to find P given A, given I, given N, okay? And negative, the A is 34,400. The factor is P given A, I is 8%, N is what? Is 8. Because you have this annuity for 8 years, right? And then we need to look at the table to find out what is the factor. So let's see, in the table, the column you're looking at is to find the P given A. So that's the column. And the row is number of years, it's 8. So the value you have for the factor is this one, 574.66. So that's 5 point. $5.7466, okay, and the final results is, don't forget about the negative sign, it is 1976.83.04, okay. So that is the present part of the present value coming from the annuities. And now you need to calculate the P03, which is a positive value converted from a future 2000. So you're looking for a present value given a future value, right? So the equation is F times a factor P slash F I% N to find out P given F, right? So positive, the F is 2000, the factor is P given F, 8% and 8 because it's at the end of the 8th year, okay? So positive 2000 and check the table. So now you are looking for P given F, and let's use another color. Okay, that's the column, and the number of years is still 8. So now the factor you're looking at is this. Okay, so just go back and then put it here, 0.5403. Positive do the calculation. It is 1080.6. So now you have already converted all the three types of cash flows back to the present time. And then you can sum them up to find out the P0. So P0 is P0 part 1 plus P0 part 2 plus P0 part 3. Okay? And P0 part 1 is negative 18,000. P0 part 2 is negative 1976.83.04. P0 part 1 is something positive. It's 1086.6. Okay? And where do you have them? This one is this. Okay? This one goes here. And this one goes here. Now it's clear. Okay? The total value is gonna be negative 214,602.44. So that is the actual cost for all those cash flows. Okay? And that cost is something you want to compare with the other option. So now let's do the same thing to the option 2. Okay, first we draw the diagram. We draw it here. So still 8 years. 0, 1, 2, 3, 4, 5, 6, 7, 8. So at the beginning, you want to pay for a new machine, new equipment, which is more expensive. It's more expensive than the used one, 60,000. And after that, every year you need to spend a little bit lower, 25,000 as your for your maintenance and operation. Okay. So it's an arrow going downward but shorter. Until the end of the 8th year. And that annuity is 25,000. But at the end of the 4th year, you're gonna have a major maintenance at 9,400. So that's something additional to this 25,000. Okay, so that's let me draw it. Let me put the annuity here. So you're gonna have additional arrow going downward, shorter one, which is 9,400. Okay, and at the end of the 8th year, you're gonna have trading receiving. Okay. Receiving for trading, excuse me, and the price is 8,000. So it's a very short arrow going upward, which is 8,000. Okay, so that's the cash flow. So on this cash flow diagram, we have how many types of cash flows? Or how many different cash flows? Let's see. You have the first part, which is a P value. we have this 9,400 compared to the time 0, it is a future value, right? So it's a F. And we have another annuity, and then we have another future value at the end of the 8th year. Okay, so we have four types of cash flows, or four cash flows. If you want to say the future cash flow of 9,400 and 8,000, they are the same type of cash flow, then that's fine. You can also say they're different amount, so they're different cash flows. So now we have four parts to convert: the present value, the first future value, the annuity, and the second future value. Okay, so right now, if you want to find out what is the present value for those cash flows, there are four parts. So P01, the first part is from the initial payment of the 60,000. Okay, and we said it is type P value, and it is cost, so it's negative. And the second part of the total present value is gonna be from the 9,400. That's a future value. Future payment for major maintenance, which is 9,400, and it is compared to the time 0, it is a future value, and it is cost, so it's negative. The third part is from the annuities, right? 25,000 for every year. So annuity of 25,000, and it is annuity. The type of cash flow is annuity. It is also negative because it's cost. And at the end of the 8th year, you have the fourth part to convert to the back to the present time. It is your salvage price at 8,000. Compared to the present value, it is a future value, so it's F, type is F, and then it is a receiving, so it's positive. So that's the four parts you want to convert back to the present time. So P01, still, that is already happening at the present time, the time 0, so you don't have to do any compounding or converting. So it is negative, of course, it's a cost, 60,000. So no calculation needed. P02, the part 2, it is from the 9,400 future value, right? So negative. The equation is for looking for present value given future value. So it's gonna be F times a factor to find the P given F, I percent, N. And the future value for at the end of the 4th year is 9,400. And the factor is P/F. I is 8%. But the number of periods is what? It's not 8, it's 4. Why? Because it's happening at the end of the 4th year. So between the year 0 and the end of the 4th year, there are only 4 periods, 4 years. Okay? So it sounds like you're going to jump 4 times back to the present. Okay, so 4 periods, which means n equals to 4 for 9,400. Okay, so here it is, n is 4. And I want to just show this to you, okay? All right, so now you're looking at the table and then find out the factor. So the table is, you're looking for present value given the future value. Of course, this table is the table of I equals to 8%, okay? So that's the table you're looking at. And then find out the column. Find the P given F. And because number of year now is 4, so the row is 4th. And here is the value, the factor you're looking at. So the factor is 0.7350. And the end results for this part is 6909. Then let's calculate the P0 from the annuity, okay? So still it's negative. You're looking for present value given annuity, so the equation is A times a factor, find the P given A, I%, and it's negative. A is 25,000. The P is P slash F, slash A. %. This annuity occurred at the end of every period for 8 times, so the n now is 8. So go check the form, the table. Now you're looking at the column of P slash A, right? To find the P given A. So that's the column. And n is 8. So here is the factor. It is 5.7466. So the final result is 143,665. Okay, the last part, P04. It is a future receiving, so it's positive. And you're looking for P value given a future value. So the equation is gonna be F times P slash F I% N. So it's a positive. F is 8,000. P slash F 8%. Now, how many years between the 8th year and the present time? It's 8, okay? So now you have to jump how many times? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So now your number of periods, the n, is gonna be 8. Okay? This from here. Okay? So I want you to pause here and then to think about the part P02 and the P04, why their n is different. Okay? This is very important. And okay, so now let's continue. It's positive, it's a receiving. So 8,000 times a factor. Okay, now let's look at the factor. It's to find the present value given future value. Okay, so this column, but the number of years is 8. So this is gonna be your factor. Okay, and that factor is 5403. 5403. So the final results for the part 4 is gonna be 4322.4. Okay, so now your P0 is gonna be the sum of the 4 parts. So P01 plus P02 plus P03 plus P04. Okay, so it is negative 60,000 plus, or you can just write the negative sign directly. Okay, negative 6909 negative 143,645 plus 4322.4. So the final is negative 206,251.6. Okay, now let's take a look at these two options. Okay, so P0 for option 1 is what? Is this, okay, let's copy it here. Negative 214,602.44. P0 for option 2 is negative. Negative means it's a cost, okay? 206,251.6. So if you want to choose which one is the better one, think about that. You need to pay either 214,602.44 or you need to pay 206,251.6. You want to choose the less negative, right? You want to choose this one because you're going to pay less, which means the option 2 is a better option. Okay, so this is a very typical question when it comes to the real cash flow in real life, and you have multiple cash flows for each option, and you want to compare which one is the better solution. Okay, and this problem is only about the cost. So you want to choose the less negative one. because you're gonna pay less.